You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Time allocation for knowledge sharing and updates is not an optional courtesy task, but a core discipline that sustains organizational reliability. Systems evolve continuously, and unless teams deliberately schedule time to capture, refresh, and share knowledge, the gap between how systems actually work and how people believe they work grows dangerously wide. That drift fuels onboarding delays, recurring incidents, and wasted effort as teams relearn what others already know. By treating knowledge work as first class, organizations safeguard accuracy, preserve hard-won insights, and make onboarding faster. Deliberate scheduling also distributes responsibility fairly, reducing reliance on a few heroic explainers who otherwise shoulder the burden of teaching and updating. Effective time allocation requires visible backlogs, predictable cadences, and protection from delivery pressures that tend to push knowledge updates aside. Done well, it turns documentation and sharing from sporadic, high-friction marathons into small, sustainable habits woven into everyday delivery. The operating model for knowledge work begins with anchoring updates as backlog items with explicit owners, acceptance criteria, and review dates. This makes knowledge creation visible alongside product features and bug fixes. For example, a backlog item may state, Update deployment runbook with new rollback procedure, steward, Alex, acceptance, validated with test environment, due, 1 week post-release. By treating knowledge like any other deliverable, teams avoid the trap of deferring updates indefinitely. This visibility also helps leaders prioritize and allocate capacity, as knowledge backlog items compete transparently with other work. Explicit acceptance criteria ensure that updates are more than cosmetic, requiring tested steps, linked decision records, or evidentiary artifacts. Review dates prevent artifacts from stagnating silently. By integrating knowledge work into the operating model, organizations signal its importance, embed accountability, and align capture with delivery rhythms, turning insight into lasting, reusable capability. Cadence design transforms knowledge upkeep from disruptive events into predictable habits. Instead of sporadic, catch-up marathons that overwhelm teams and introduce errors, regular rhythms spread effort evenly. Weekly micro-updates handle small adjustments such as linking decisions or clarifying steps in runbooks, while monthly deeper refresh cycles validate critical artifacts. For example, a team might reserve 15 minutes at the end of each sprint review for micro-updates, and a 2-hour monthly session for reviewing high-risk documents like incident playbooks. This cadence balances small, continuous attention with periodic deep maintenance, preventing both neglect and overload. Predictability reduces cognitive overhead, as contributors know when updates will happen and can prepare accordingly. It also ensures that knowledge upkeep survives delivery pressure, as cadences are planned rather than optional. Over time, cadence design embeds documentation and sharing into the cultural fabric, making knowledge freshness as routine as testing or integration. A knowledge backlog structures work thematically, ensuring that time is spent where it has the most impact. Themes include runbooks, standards, decision records, and FAQs, organized by risk level, usage frequency, and support pain. For example, runbooks tied to high-severity services may rank higher than FAQs used occasionally. Sequencing backlog items this way maximizes return per hour invested. The backlog also makes debt visible. Missing or outdated artifacts appear as explicit entries rather than hidden liabilities. By managing knowledge systematically, teams prevent drift between real operations and documented understanding. Prioritization avoids wasting energy on obscure artifacts, while high-volume or high-risk areas stagnate. Like product backlogs, knowledge backlogs evolve continuously as new gaps are discovered. This structure ensures that captured time is spent wisely, turning scattered efforts into coherent, cumulative improvements that strengthen delivery resilience. Expanding the definition of done to include documentation updates ensures that knowledge capture is inseparable from delivery. When a feature bug fix or release is completed, teams also update relevant artifacts, decision records, runbooks, or compliance evidence. For example, a definition of done may require that new features include updated architecture diagrams and links to standards. This practice prevents decay, where work is finished technically but leaves knowledge behind. It also distributes responsibility evenly, as every team member contributes to documentation as part of their work. Expanding done integrates knowledge upkeep into the natural flow of delivery, avoiding "will update docs later" traps. Over time, this builds reliability, as artifacts remain synchronized with reality. It also normalizes updates, reducing resistance by making them expected, not extra. Embedding documentation into done criteria transforms capture from occasional events into continuous reinforcement of organizational memory. Triggered updates link specific events to required refresh tasks, ensuring that knowledge remains current after meaningful changes. Incidents, releases, control changes, and audits all generate insights that must be captured. For example, when an incident reveals monitoring gaps, a triggered update requires playbooks and dashboards to be revised within a set time frame. By pairing events with tasks, teams avoid stale guidance and ensure that lessons flow into practice immediately. Triggered updates also align with accountability, as named stewards are responsible for executing them. This event-driven model reduces reliance on memory or goodwill, embedding capture into standard workflows. It also accelerates resilience, as improvements are documented while context is fresh. Over time, triggered updates create a self-correcting knowledge system, where artifacts evolve in lockstep with reality, preventing the dangerous drift that occurs when updates lag behind practice. Expiry and stewardship policies add further safeguards, ensuring that responsibility for accuracy does not vanish into collective neglect. Critical artifacts are assigned best before dates, after which they must be reviewed or refreshed. Named stewards are accountable for these updates, with automated reminders or dashboards highlighting upcoming expirations. For example, an incident runbook may expire after 12 months unless the steward validates and reapproves it. Expiry policies prevent teams from relying on outdated guidance unknowingly, while stewardship ensures accountability. This system also spreads responsibility across roles, reducing overdependence on a few experts. Redaction, archiving, or updates are handled by stewards as needed. By embedding expiry and stewardship into time allocation, organizations prevent silent decay and maintain trust in their repositories. This discipline transforms knowledge systems into living assets, continuously validated and improved rather than left to wither unnoticed. Balancing synchronous and asynchronous methods improves both efficiency and inclusivity. Concise written updates provide durable records that anyone can reference later, while live sessions are reserved for nuanced topics requiring dialogue. For example, a short update might clarify a new standard via an internal wiki entry, while a synchronous session might address the implications of shifting compliance requirements. Asynchronous methods prevent meeting overload, ensure global reach, and preserve context for later reuse. Synchronous sessions create alignment and surface questions that written updates cannot anticipate. This balance reduces wasted time and ensures that each mode is used where it adds the most value. Over time, this mix normalizes knowledge capture as both a written discipline and a collaborative practice, ensuring that information is both durable and understood. Time allocation across synchronous and asynchronous channels maximizes clarity, minimizes waste, and sustains global collaboration. Office hours and clinics lower the barrier for capturing and sharing knowledge in real time. Subject matter experts make themselves available for scheduled drop-in sessions where questions are answered, common patterns are discussed, and insights are captured into artifacts. For example, a weekly reliability clinic may address recurring support issues, updating FAQs and runbooks based on the questions raised. These sessions turn isolated inquiries into shared learning, ensuring that one person's confusion becomes the organization's clarity. Clinics also reduce the load on experts, consolidating questions into predictable time blocks. Over time, office hours strengthen both accessibility and artifact quality, as real-world questions continuously feed back into the knowledge system. By allocating time for clinics, organizations create a sustainable channel for knowledge transfer, bridging the gap between documentation and lived expertise while avoiding the inefficiency of repeated one-on-one explanations. Onboarding allocations dedicate time for newcomers to consume curated primers and shadow experienced colleagues, ensuring they gain reliable context without overburdening experts. Without this allocation, knowledge transfer depends on a handful of hero explainers, creating burnout and inconsistency. Structured onboarding paths route new members through golden threads of artifact standards, playbooks, and FAQs before they shadow practices like incident response. Allocating time ensures that learning is not squeezed into delivery pressure but treated as critical investment. This accelerates time to independent contribution while distributing the teaching load. Onboarding allocations also reinforce culture, signaling that sharing and learning are expected norms. By embedding structured time, organizations transform onboarding from informal improvisation into a reliable system that scales. This practice sustains team health and ensures that fresh talent becomes effective quickly, reinforcing resilience and reducing dependency on a few overloaded experts. Cross-team time blocks coordinate communities of practice and integration reviews. These scheduled sessions reduce duplicate effort, surface interface risks, and strengthen coherence. For example, scheduling joint reviews between development and operations teams can identify gaps before they affect users. Communities of practice benefit from regular cross-team slots that prevent drift into silos. Time blocks also ensure fairness, giving structured space for knowledge sharing alongside delivery tasks. By coordinating across teams, organizations prevent fragmented insights and align standards, tools, and practices. Over time, these blocks reduce rework and defects by catching issues early and harmonizing approaches. Allocating cross-team time transforms knowledge sharing from optional collaboration into an institutionalized safeguard, ensuring that integration risks are identified and that learning flows across boundaries predictably rather than sporadically. Docs as code practices raise the quality and traceability of knowledge by aligning it with software engineering workflows. Documentation is treated as code, versioned in repositories, reviewed through pull requests, and checked with automated validation. For example, a change to an incident runbook may be reviewed by peers before merging, ensuring accuracy and clarity. Automated checks validate links, formatting, or metadata, reducing errors. Version control provides transparency, showing how knowledge evolved and who approved it. Docs as code also integrates updates with delivery pipelines, triggering reminders when artifacts require refresh. By aligning knowledge with tooling engineers already use, adoption increases and quality improves. This practice embeds traceability and rigor, making documentation as reliable and auditable as the systems it describes. Over time, Docs as code transforms repositories into living, trustworthy assets, reducing friction and ensuring that updates are natural, not optional. Interrupt management balances urgent support needs with planned knowledge tasks. Without protection, scheduled updates are continually sacrificed to firefighting, leaving knowledge decay unchecked. Queues and rotation systems manage incoming support, ensuring that deep work time is preserved for those assigned to knowledge upkeep. For example, a weekly rotation may assign one engineer to handle incoming support questions, freeing others to focus on documentation tasks. Escalation protocols ensure that critical issues are still addressed, without overwhelming the system. By distinguishing between interrupt-driven work and scheduled tasks, organizations protect knowledge allocation from erosion. This discipline ensures that both service responsiveness and knowledge health are sustained. Over time, interrupt management builds predictability, reducing stress and enabling balance between immediate needs and long-term resilience, ensuring that neither is neglected. Measurement models prove whether time spent on knowledge capture improves outcomes. Metrics include update latency, the time between change and documentation, update artifact usage rates, and ties between documentation gaps and incidents. For example, if faster updates correlate with reduced mean time to restore, the benefit is clear. Tracking onboarding time against curated artifact paths demonstrates value. Metrics also reveal weak spots, such as artifacts rarely used, suggesting redundancy or irrelevance. By quantifying impact, organizations justify continued investment and refine allocation. Measurement also reinforces accountability, ensuring that time spent is purposeful, not ritual. Over time, these models demonstrate that knowledge upkeep is not cost but leverage, directly reducing risk and accelerating delivery. This evidence strengthens cultural buy-in, turning knowledge capture from abstract good practice into proven driver of performance and reliability. Compliance alignment ensures that retention, approval, and traceability requirements are embedded in daily update routines. Instead of scrambling at audit time, repositories automatically capture evidence of review, stewardship, and version history. For example, a decision record may log its approval chain and expiry date as part of standard metadata. These practices reduce audit stress and ensure credibility, proving that knowledge upkeep satisfies external as well as internal demands. Compliance integration also strengthens trust among regulators, partners, and stakeholders, showing that agility does not undermine accountability. By aligning compliance with knowledge work, organizations replace bolt-on paperwork with embedded assurance. This not only saves time, but also reinforces discipline, making knowledge systems both agile and trustworthy. Over time, compliance alignment becomes a competitive advantage, demonstrating that fast, resilient delivery can coexist with robust governance. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Scheduling heuristics help teams place knowledge tasks in the most effective moments, matching the complexity of the work to the cognitive load of the cycle. Short updates, such as clarifying a runbook step or adding a link to a decision record, are best slotted near the event that created the context. For example, a developer may capture an FAQ entry immediately after resolving a support ticket while the details are fresh. Deeper refreshes, such as revising standards or refactoring a playbook, fit better during calmer points like the end of a release cycle or scheduled maintenance windows. This balance prevents both fatigue and oversight, ensuring updates are timely but not rushed. Scheduling heuristics also reduce procrastination, as knowledge capture feels natural and adjacent to work rather than an added burden. Over time, this alignment turns updates into sustainable habits, embedding documentation and sharing seamlessly into delivery rhythms. Role rotation spreads knowledge responsibilities across the team, preventing silos and reducing burnout. Without rotation, the same people often end up maintaining artifacts or leading knowledge-sharing sessions, creating dependence and fatigue. Rotation assigns stewardship, presenter slots, and documentation duties on a recurring basis, ensuring that everyone develops skill in contributing. For example, one sprint a junior engineer may update a runbook under review, while in another sprint a senior facilitator may lead a retrospective review. This practice builds resilience, as no single individual becomes the only source of truth for critical artifacts. It also develops broader competence, teaching all team members to capture, structure, and present knowledge effectively. By rotating roles, teams democratize responsibility and reinforce that knowledge stewardship is part of everyone's job. Over time, rotation strengthens trust and continuity, ensuring that knowledge practices survive staff changes and avoid dependency on a handful of experts. Pair write and review patterns elevate the quality of knowledge artifacts while building collaborative skill. Writing in pairs reduces the burden on any one contributor and mirrors proven practices like pair programming. One person drafts, while the other reviews in real time, catching errors and clarifying phrasing before publication. For example, a runbook may be drafted by an operator while a developer ensures technical accuracy. Review adds polish and confirms usability, reducing the risk of confusing instructions or overlooked steps. Pair writing also builds shared understanding, as two perspectives converge into one artifact. This process doubles as training, as less experienced team members learn documentation techniques from peers. Over time, pair writing creates cultural reinforcement that knowledge work is collaborative, not solitary. It ensures that artifacts are both clear and credible, strengthening user confidence in repositories. Pair write and review practices sustain quality and resilience by combining precision with shared accountability. Curation boards act as librarians for organizational knowledge, ensuring repositories remain lean, searchable, and trustworthy. Boards triage suggestions, consolidate duplicates, and retire obsolete entries. Without this filtering, repositories grow bloated, eroding trust as users sift through stale or conflicting artifacts. For example, if 3 runbooks exist for the same system, a curation board may merge them into a single, validated version. Curation also prioritizes maintenance, assigning stewards to high-traffic artifacts and archiving outdated ones with clear markings. This governance balances inclusivity with discipline, ensuring that contributions are welcomed but not left unchecked. Boards also set norms, clarifying what constitutes a complete artifact and enforcing standards. Over time, this role sustains the health of the knowledge ecosystem, preventing decay and overload. By investing in curation, organizations signal that knowledge is not only captured but cared for, reinforcing trust and encouraging consistent reuse. A knowledge debt register provides visibility into missing or known bad artifacts, preventing deferred updates from becoming permanent gaps. Like technical debt, knowledge debt accumulates silently when updates are skipped or delayed. A register logs each item with an owner, due date, and risk level. For example, after an incident, the team might note that the failover procedure needs rewriting, due within 2 weeks, marked high risk until complete. This visibility prevents drift, ensuring debt is managed rather than forgotten. Registers also enable prioritization, as high-risk items receive attention first. Leadership gains transparency into where gaps exist, supporting resource allocation. Over time, tracking knowledge debt normalizes the idea that documentation and updates are as critical as code or features. By maintaining a debt register, organizations treat knowledge gaps with the same seriousness as other risks, sustaining reliability and ensuring learning is preserved. Calendar design protects recurring blocks for knowledge work with the same rigor as delivery ceremonies. Without protected time, documentation and sharing are the first to be sacrificed under deadline pressure. By embedding knowledge sessions directly into calendars, such as bi-weekly refresh reviews or quarterly repository audits, teams ensure updates survive. These blocks must be defended like stand-ups or sprint planning, with leadership modeling respect for their importance. For example, a 1-hour update clinic every 2 weeks may focus exclusively on runbook and standard revisions. Protecting time also reduces guilt, as contributors know they are not neglecting delivery but fulfilling scheduled obligations. Over time, calendar discipline transforms knowledge capture from an afterthought into a recognized practice. This design ensures continuity, preventing decay and signaling culturally that updating knowledge is legitimate work, not a distraction. Calendar protection reinforces reliability, embedding knowledge upkeep as part of organizational cadence. Remote-first practices keep knowledge sharing effective across distributed teams without generating meeting sprawl. Techniques include recorded microbriefs, annotated examples, and threaded Q&A. For example, a short video explaining a new workflow can be recorded, captioned, and posted with annotations for asynchronous consumption. Threaded discussions allow questions and clarifications to accumulate transparently, building mini FAQs. Remote-first design prioritizes durability and inclusivity, ensuring that time zones and work styles do not exclude participants. It also prevents overload, replacing redundant live sessions with asynchronous resources that persist. By embedding these practices, teams reduce friction, strengthen accessibility, and broaden participation. Remote-first norms align knowledge capture with modern work environments, sustaining resilience and adoption. Over time, these practices make knowledge sharing scalable across global teams, ensuring that learning is not bound to location or live attendance, but accessible whenever and wherever needed. Vendor and partner exchange cadences extend knowledge alignment beyond organizational boundaries. Interfaces between companies often generate recurring issues when documentation is mismatched or updates are unsynchronized. Scheduled exchanges, such as quarterly integration reviews or shared playbook updates, reduce these risks. For example, partners may review SLAs, update joint escalation paths, and synchronize interface documentation. These cadences prevent surprises, aligning expectations across boundaries. They also strengthen trust, as partners see reliability in proactive communication. By institutionalizing exchanges, organizations embed shared stewardship, ensuring that cross-boundary systems remain consistent. Over time, these cadences reduce support thrash, improve collaboration, and sustain operational resilience. Knowledge is no longer siloed within one entity but flows across ecosystems responsibly, reinforcing that reliability depends on shared clarity as much as technical integration. Recognition mechanisms value stewards and contributors, countering the cultural bias toward only rewarding new feature delivery. Without recognition, knowledge maintenance is treated as invisible labor. Mechanisms may include formal credit in performance reviews, badges for steward roles, or public appreciation in retrospectives. For example, highlighting a steward who refreshed a critical security playbook reinforces the value of maintenance. Recognition motivates contributors, showing that their updates improve outcomes as much as shipping code. It also balances incentives, preventing neglect of critical artifacts. Over time, recognition shifts culture, embedding knowledge upkeep as a celebrated part of professional excellence. This cultural reinforcement sustains repositories and ensures quality. Recognition practices counter burnout, encouraging contributors to continue refining and maintaining artifacts. They send a clear message: stewardship is valued, essential work, not peripheral activity. Toolchain integration surfaces update prompts in the natural flow of work, turning intentions into routine behavior. For example, pipelines may generate reminders to update runbooks after deployments, or ticket templates may include a checklist for linking decision records. These nudges embed knowledge capture at the right moment, reducing reliance on memory or goodwill. Integration also enforces standards, ensuring that artifacts are linked, versioned, and reviewed consistently. By aligning capture with tooling, updates become a seamless part of workflows rather than an extra step. Over time, these prompts normalize behavior, ensuring consistency and reducing missed updates. Toolchain integration transforms knowledge upkeep from manual responsibility into systematic habit, increasing resilience and reliability. This practice ensures that knowledge freshness is reinforced automatically, reducing risk and strengthening trust in organizational memory. Risk-based prioritization ensures that limited time for knowledge work delivers the greatest impact. Not all artifacts carry equal weight. Runbooks tied to safety, compliance, or high-volume support should take precedence over low-risk, low-use documents. For example, updating an emergency failover procedure ranks higher than revising an internal style guide. Prioritization frameworks weigh risk, frequency of use, and pain caused by gaps. This ensures that captured time reduces the most consequential confusion and accelerates the most critical workflows. Risk-based prioritization also provides transparency, showing stakeholders why certain updates come first. Over time, this discipline ensures that knowledge work is not just consistent, but impactful. It channels effort toward resilience and compliance, making scarce time deliver measurable outcomes. By aligning allocation with risk, organizations strengthen the link between knowledge upkeep and operational reliability. Outcome review validates whether time allocated to knowledge work produces benefits. Metrics correlate documentation freshness with defect rates, onboarding time, and mean time to restore. For example, if onboarding time decreases after curated primers are refreshed, the value is clear. Reviews also identify gaps. If incident response still suffers delays, updates may not have addressed the right artifacts. By reviewing outcomes, organizations ensure that knowledge capture is delivering ROI. Reviews also provide stories that motivate teams, showing how an updated runbook reduced downtime or how a clarified FAQ prevented repeated confusion. Over time, outcome reviews refine practices, ensuring that allocation remains effective. This evidence proves that knowledge upkeep is not overhead but leverage, improving quality, speed, and resilience. Outcome review closes the loop, sustaining buy-in and demonstrating the tangible value of disciplined time allocation for knowledge sharing. Anti-pattern vigilance ensures that time allocation practices remain effective. Common pitfalls include giant quarterly doc days that overwhelm teams, private note hoards that fragment knowledge, and slide-only repositories that fail to provide durable, searchable text. These anti-patterns waste time and undermine trust. Corrective practices replace them with incremental updates, shared repositories, and text-first artifacts that scale. By naming and addressing anti-patterns openly, organizations prevent drift into bad habits. Vigilance also reinforces cultural norms, reminding teams that knowledge upkeep must be incremental, inclusive, and durable. Over time, this awareness ensures that repositories remain trustworthy and usable. Anti-pattern vigilance prevents waste, strengthens credibility, and preserves the value of scheduled time. It transforms knowledge capture from a checkbox activity into a disciplined, results-oriented practice. A sustainment plan ensures that knowledge upkeep remains healthy as teams and technologies evolve. This includes periodic audits to check artifact quality, steward succession to prevent gaps when people move on, and pruning rules to retire outdated content gracefully. For example, a quarterly audit may flag artifacts past their best before date, triggering steward review. Succession ensures continuity, as responsibilities transfer smoothly to new contributors. Pruning prevents clutter, preserving repository trust. Sustainment planning embeds resilience, ensuring that practices adapt alongside organizational change. Over time, sustainment prevents decay and keeps knowledge capture aligned with current reality. By institutionalizing audits, succession, and pruning, organizations ensure that time allocation remains effective, efficient, and culturally reinforced. This discipline ensures that knowledge systems remain assets, not liabilities, compounding value year after year. Time allocation synthesis highlights that keeping organizational knowledge current requires deliberate structure, not heroic, last-minute efforts. Visible backlog items with owners and acceptance criteria embed accountability. Predictable cadences and scheduling heuristics make updates sustainable. Stewardship, expiry policies, and recognition ensure quality and motivation. Integration with toolchains and workflows embeds updates seamlessly into daily work. Risk-based prioritization channels limited time toward the most consequential artifacts, while outcome reviews validate ROI. Anti-pattern vigilance and sustainment planning preserve long-term effectiveness. Together, these practices make knowledge upkeep routine, reliable, and impactful. The result is a living organizational memory that accelerates onboarding, reduces incidents, and ensures alignment between system reality and shared understanding. Time allocation is not just about scheduling. It is about building resilience by ensuring that learning remains fresh, usable, and trusted. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.